As expected, the new ground effect aero puts the floor in the center of the development. In Austin, Hamilton and Leclerc got disqualified because their plank was worn too much. The regulations allow 1 mm wear. Leclerc had 1.3 mm, Hamilton had 3 mm wear. But to fully understand how this all works and what teams are trying to get an advantage, we will put ourselves in the shoes of an F1 engineer and design a plank. First of all, why is there a plank? After the Senna crash 1994, it was decided to fit a wooden plate underneath each F1 car. The thickness is set to 10 mm and the minimum thickness after a race is set to 9 mm. That way, the FIA could avoid teams from setting up the car too low and avoiding bottoming out. Because when a car hits the ground, you can choke the flow underneath, which means you lose a lot of downforce, which is a safety risk. On the other hand, they could prevent cars from driving too low, resulting in more downforce and hence being faster. So let's have a look at what these regulations look like. There's a big article 359 telling you about the plank itself. The paragraph that got Hamilton and Leclerc disqualified is paragraph E. So their plank had less than 9 mm after the race. The funny thing about the regulations since 2022 is that you won't find any geometrical data in this article. It just says the geometry of the plank must conform to RV plank. RV plank means reference volume plank. So we have to go to the end of the regulations and find the definition of RV plank. Okay, so that is our car. We called it plank assembly. We can see there's the car in the tree and we have one plank part. You can see the origin of the coordinate system is underneath the front axle. This is our reference point XF, which is the point on the reference plane underneath the front axle center line. And then we have our rear wheel center line, which is at this model at 3600 mm. And we have XR here, which is again the middle point on the reference plane under the rear wheel center line. So that is our car and we want to design a plank for this now. The floor is designed to the reference plane and we design the plank on the reference plane now and extrude it in Z direction. So you can see here, this is the article 39. That's the plank article that defines the dimensions. And you can see these points and we are designing these points now. We take the XF, so the front reference point, and now we just type the coordinates that are in the regulations. So 430 and 0. That's our first point. That is point A. You can see it's at the very front of the floor. And we rename this part, or this one point, so we know what it is. We always rename the things exactly to what it is in the regulations, because if we want to check the regulations again, then we have exactly the same wording in design, in the construction, and in the regulations. Now we rename all these points to A, B, C, D, and E. And then we type in the coordinates and then we can see a little bit better what we are doing here. And that is the thing about these regulations. You can only see what they are talking about if you design these points or these volumes. Otherwise, you don't really understand what they want. So B is 430 and 75. Then we take C, 690 and 125. So you can see that the plank is a little bit narrower at the front, and only now it gets the full thickness. Now, the special thing about D is we need to change the reference point to XR. So this is dimensioning the point from the point XR, which is at the rear wheel axle. And now we have minus 600 and 0 for D. Okay, and now we have these points, and now we just connect these points. So we have a line between A and B, and then between B and C and D, and D and E. And now you can already see the shape of the plank. Okay, and we need another line between E and A, so we can close the profile, and we can build a block from it later. Okay, so this is what the regulations tell us about RV plank. So this is the profile of it. We now quickly change to a different workbench so we can join all these lines to one profile. So we go to shape design. So what we are seeing here is CATIA V6, so 3D experience. That's the same program the F1 teams are designing the cars. So we join these lines to a profile, call it plank profile. And now we can use this in part design to create a pad. And the regulations say extrude this profile in Z direction minus 10 millimeters. So we designed it on the reference plane, and it should go towards the ground. So we can see this here, it's 39.3. So once the surface is fully defined, it must be extruded along Z to Z minus 10. So this is the 10 millimeter thickness that we talked about. Yeah, just make sure that it goes the right direction. Okay, so now we have this half plank underneath. Now let's go to article 39.2, which tells us more about the fillets around this plank. So we switch the car off so we can grab these edges a little bit better. We can also switch off the construction now. We don't need to see the points anymore because only the plank itself as a volume is interesting now. And it says at vertex B, there should be a fillet with 25 millimeter radius. So that is the front corner. And let's take our fillet tool, grab this little edge, and then we type 25 millimeters, and that's the first fillet. The second fillet should be 2000 millimeters at vertex C. So that is the next edge. And the radius is so big because it's such a huge angle. So let's type 2000 here, and that is our large radius. So that is the basic plank shape that the regulations require. Okay, so the next article is 39.4, and it tells us something about the chamfers around the plank. So there's a pretty huge chamfer at the back, 6 millimeter times 150. So we take the chamfer tool, change it to length, so we can type exactly what the regulations tell us to. And yeah, just type 6 and 150. And this is what it looks like. Okay, so that's the first chamfer done. And then we do this second one. So to all remaining lower edges, which means that basically this one and that one, which includes all the other edges because we applied the fillets before. So that's also a reason why the regulations are written that way. So we type the values 6 and 12, and this is what the basic plank shape looks like with fillets and with chamfers. Okay, so the next thing that needs to be done is Article 395, and it tells us more about these measuring holes. So the holes have 50 millimeter diameter, and they're in certain locations, and these are the important bits because this is where the plank is going to be checked. So we create a sketch in our construction folder. We will draw this on the reference plane as well. Everything with the regulations is been done on the reference plane. And you can see the 3 dimensions they give us here, all these 3 points. So the first one should be 500 millimeters behind the front reference point. So let's design a circle somewhere, and now we constrain it to the correct location. So we want this to be in the center of the car, so we constrain it to the x-axis. So we just say coincidence, and then it's always there. And now we just need the length to the forward reference point. We click it in the tree, so it's a bit more reliable than clicking something on the screen. And change this to 500, and that's our first hole. Okay, so now we can go to the second one. It's also referenced from the forward reference point. And we design it somewhere again and dimension it to the right location first. So that's 75, and in length it's 1080. Okay, and now we can give it the correct diameter. It's good if you give it the right diameter later on because it's easier to grab a larger circle. And now the rearward measuring point is quite interesting because the teams have some room for interpretation, so they can choose where they put this point. It could be at 825 or 1025 from the rearward reference point. So you as a team can choose where you want the FIA to check your floor. That is not the same dimension for every team. So again, we design the circle somewhere. Now we constrain it to the correct location. We do coincidence with the x-axis again, and now we dimension it from the rear. So we grab this in our model tree. And let's do one dimension first to show you where this could be. So that's 825. So that is the most rearward position that is allowed according to the regulations. And now we can change it to 1025. So the teams have this 200 millimeters of room to play with. So they can push this measuring point further forward or further backwards between 825 and 1025. So now we have the plank, we have these holes, we have these circles first, and now we can use these circles that we were just drawing in the sketch to do a pocket. So we cut through the plank. And that's it. That is half of the plank done. Now we just need to mirror it, and that's our plank being finished. So, yeah, first of all, we wanna mirror everything, not just the pad, because otherwise we can't take the holes with us. If we do this, you can see what happens here. So it's only half of the holes. So instead, we just grab the whole part body and then mirror it on the ZX plane, and that is our plank. So that is what you can see underneath every Formula 1 car. Everything about this is fixed, as we could see. Only the rearward measuring point has like 200 millimeters of room for the teams to play with. And then if we switch the car on, you can see how it looks like underneath the car. And that is the standard plank with the 4 measuring points. So now we have our plank geometry. Now we go back to Article 359 to learn more about how the plank should be produced and fixed. It says the plank material is free. Just the density should be between 1.3 and 1.45. Teams usually use wood or plastic. So also that is not a standard material. And the plank can also consist of 3 pieces if you want. And then there are some details about plank pockets in the forward area. Let's talk about how to fix the plank. The screws shouldn't be smaller than M6 and should be 10.9 or 12.9 grade. And then the regulations allow to have skids. They must be machined from a solid piece of titanium and should protect the plank from wearing out too quickly. Since the plank is only being measured at these 4 holes, you don't really care about wear anywhere else and position the skids around the holes. And this is also where you fix the plank. Now there's the interesting paragraph S. In the forward area it needs to be fixed with 0 degree of freedom. So does that mean there is some freedom at the rear? So let's go to the floor flexibility rules. It's rule 3.15.8 for the central floor, and now it gets really interesting. Remember, we designed the holes with 50 mm diameter in the plank. Now the car will be supported by 3 pads with 70 mm diameter in these 3 measurement points. So the car will rest on the plank. And here a deflection of 2 mm is allowed. 2 mm is quite a lot considering it's 20% of the overall plank thickness. And there's a second test where they put the car on 40 mm pads. So now the car rests on the floor and not on the plank. Now the deflection can only be 0.2 mm, so basically nothing. So you see where this is going. The current regulations don't allow a deflection for the floor, but they do allow the plank to deflect by 20%. And that's quite powerful, because if the teams can drive lower, they get more downforce with these ground effect cars. And if they can drive lower and even get away with it, because they have a flexible plank, their car is quicker and legal. So teams are working very hard on foam material between plank and floor, or even more so between skids and floor. They even design little springs inside skids to allow maximum deflection, but when the FIA is testing the floor flexibility, it's fine because the car rests on 40 mm pads and not on the skids. So checking an F1's car's floor is pretty tricky. It's not just about measuring the plank thickness, it's also about measuring the skids themselves. Because teams even work with elastic material. And the regulations say next to the measurement point the stiffness needs to be 90%. And also teams have different setups for planks and skids every few races. If you want to check all that, you need to remove the skids from the car. And that is sometimes tricky. Haas says their skids can be removed within 2 minutes, but others bond them to the plank, so it's extra tricky for the FIA to check. Basically, there are 2 strategies to get on top of all that. One would be to make plank and skids standard parts so they are the same for everyone. And the other solution would be to completely get rid of plank and skids. Since Spa 2022, the FIA is measuring amplitude and frequency of cars bottoming out. So they can see which car might wear the plank out too much. By the way, that's also the reason why they pulled these 2 cars out in Austin, and 2 others as reference. So if someone is too low and hitting the ground too hard, it's okay as long as the driver can take it. And if it's too much, the FIA sees it in the data and the car will be disqualified anyway. Of course, teams don't want that, because right now they can still get advantages from their plank detail design. And also in the FIA, there is a group which likes to keep the rules slightly open and complicated so they can show their power of disqualifying cars every now and then. So what do you think about this? Let me know in the comments below, and if you are interested in working in F1's aero development, check out my online career Accelerator program. It's an intensive 6-week course which helps you to prepare yourself for a career in F1 with CATIA V6 licenses and lots of valuable knowledge you can only get from people who worked in the industry. The first people who finished this course are already working in F1's aero departments, so you could be the next one. Check out the course with the link below and make sure you state that you found the course through my YouTube channel. See you at the next one.